Find all integers x that satisfy x square plus x by x minus 1 whole square equals 8. We suggest you to pause the video for a couple of minutes and try this out on your own. Now let's move on to the solution. If we multiply both sides of the equation by x minus 1 whole square, we get x square times x minus 1 whole square plus x square equals 8. Upon expansion, we get x to the 4 minus 2x cubed plus 2x square minus 8 equals 0. Now this is a fourth degree equation, that is a quartic equation, whose solution, unlike a quadratic formula, is very complicated. Neither does there seem to be any visible factorization. Let us try a different approach to solving this problem. The main difficulty in trying to solve this is simply the existence of x minus 1 in the denominator. So we will introduce a new variable. Now we will do a substitution. The denominator is simplified by the introduction of a new variable t. So if we let x minus 1 be t, this implies that x is t plus 1. We just added 1 on both sides to get x equals t plus 1. This substitution now changes the original equation to t plus 1 whole square plus t plus 1 by t whole square equals 8. Now t plus 1 by t is nothing but 1 plus 1 by t. So now we get t plus 1 whole square plus 1 plus 1 by t whole square equals 8. Now expanding using the familiar formula like a plus b whole square equals a square plus b square plus 2ab, we will get that t square plus 2t plus 1 plus 1 plus 2 by t plus 1 by t square equals 8. Now we can regroup the terms with similar coefficients to get t square plus 1 by t square plus 2t plus 2 by t plus 2 minus 8 equals 0, which is nothing but t square plus 1 by t square plus 2 times t plus 1 by t minus 6 equals 0. Now a small insight will help us a lot. Let's remark that we have the following identity. T plus 1 by t whole square equals t square plus 2 plus 1 by t square. With a little simplification, we get t plus 1 by t whole square minus 2 plus 2 times t plus 1 by t minus 6 equals 0. We just isolated the t square plus 1 by t square term in the identity to get this following equation. T plus 1 by t whole square plus 2 times t plus 1 by t minus 8 equals 0. Notice that this seems to be a standard quadratic equation, that is ax square plus bx plus c equals 0, but just not in the variable x. This seems to be a quadratic equation in the variable t plus 1 over t. We can introduce another new variable s to help us solve the equation. Now we make another substitution to match with the standard quadratic equation, that t plus 1 by t equal s. The equation is now reduced to a quadratic in s, which is nothing but s square plus 2s minus 8 equals 0. Now we can solve this quadratic equation by a little factorization. We can split the 2s as the sum of minus 2s plus 4s. Now we can factor out an s from the first two terms and a 4 from the next two terms. So now we can rewrite this as s minus 2 times s plus 4 equals 0. Now this just means that s is either 2 or s is minus 4. We now have to plug these values back into the substitutions we made. There arise two different cases, one for each value of s. Case 1 is when s equals 2. Remember that we let t plus 1 by t equals s, so now we have t plus 1 by t equals 2. We can multiply with t on both sides to get t square plus 1 equals 2t. Now we can subtract 2t from both sides to get t square minus 2t plus 1 equals 0. Now this is just t minus 1 whole square equals 0. This implies t equals 1. But recall that we let t plus 1 be x in our first substitution. So putting t equals 1 will now mean that x equals 2 is a solution. Case 2 is when s equals minus 4. So now we get t plus 1 by t equals minus 4. We multiply with t on both sides. Now we add 4t on both sides. Now we make use of a theorem. Let f of x equals x squared plus bx plus c, where b and c are both integers. If there exists an alpha such that alpha is an integer and f of alpha equals 0, this just means that alpha is a root of f of x, then alpha divides c. This theorem is also known as the integral root theorem for quadratic equation. Now, by the integral root theorem, if an integer is a root of an equation, then that root has to divide the constant term of that equation. Here, the constant term is 1, whose factors are 1 and minus 1. But notice that neither 1 nor minus 1 are roots of the equation. You can simply check it by doing a manual calculation. So the values of t that satisfy the equation are never integers, which means that t is not an integer. Since 1 is an integer and t is not an integer, we get that t plus 1 is not an integer. But recall that we let t plus 1 be x. So this just implies that x is not an integer in case 2. Hence x equals 2 is the only solution which we got through case 1. Alternatively, one can find another simple solution to case 2 using a well-known formula. Try it on your own and comment below your solution. Here is a nice exercise for those interested. This problem is taken from the Oxford Mathematics Admission Test 2023. Find all real solutions x to the equation x to the 4 plus x cubed minus 10x squared plus x plus 1 equals 0. Do give it a try, and thank you for watching. Hope you learned something new.